Hello everyone. In this video, I'm going to talk about restore points in Oracle, what they are, how to create them, and the different types available. The best way to learn is by doing. So we'll go through a complete hands-on session to understand the concept in detail. Let's first understand what a restore point is. A restore point is basically a named marker in the database's reduce stream. It allows you to roll back or flashback your database to a specific point in time. The best part is that it doesn't require you to manually find out the SCN or timestamp. Oracle takes care of that automatically. It is also much faster than restoring the database from an RMAN backup, which makes it very useful in real world scenarios. Typically, restore points are used during testing, patching, application upgrade, or database upgrade, or any kind of schema changes. Situations where you might want to quickly return your database to a known good state if something goes wrong. Alright, now we'll see types of restore points in Oracle. First one is normal restore point. A normal restore point is a named alias for a specific system change number or a point in time within the database. Think about it like when we perform point in time recovery of database, it requires SCN number or timestamp. But in this case, you don't have to remember timestamp or SCN. You just can use restore point name to perform point in time recovery. When you create a normal restore point, this metadata restore point does not stay forever. This is retained for a period determined by control file record keep time initialization parameter. We'll discuss this parameter in detail in the coming slide. A normal restore point depends on the flashback retention policy db underscore flashback underscore retention underscore target parameter and the FRA space availability. DB flashback retention target is an initialization parameter that specifies the desired window of time for which Oracle should try to keep flashback logs. Second one is guaranteed restore point. A guaranteed restore point is a restore point that ensures you to revert a database to a specific known good state, regardless of your flashback retention policy. Unlike a normal restore point, a guaranteed restore point is never automatically deleted and must be manually dropped. When you create a guaranteed restore point, the database retains all necessary flashback logs which are required to restore the database. Now let's understand the parameters which are important for this restore point concept. First one is DB flashback retention target and second one is control file record keep time. DB flashback retention target, this specifies the target duration in minutes for which the database should retain flashback logs. Default value is 1 day. This is used only when flashback database is enabled. So what does it mean? It means if this is set to 1 day, Oracle will try to retain enough flashback logs to flashback the database up to 1 day in the past. But it's a target, not a guarantee. If FRA runs low on space, older flashback logs can be deleted automatically. Now, coming to the second parameter, control file record keep time. It controls how long the information about backups, restore points stay in the control file before it is overwritten. The control file in Oracle has a limited size that's determined automatically when the database is created. It can grow slightly if needed when more records or entries are required, but it is not unlimited. Oracle allocates sections inside the control file for different types of records such as data files, redo log groups, archive logs, restore points, log history, etc. Each section has a maximum number of records in it can hold. So what happens when it gets full? When a section, for example archive log history, reaches its limit, Oracle starts overwriting the oldest records in that section based on the value of the parameter control file record keep time. So the question comes to mind, can the control file expand? Yes, Oracle can enlarge the control file automatically within the limits when a section runs out of room. However, it won't grow indefinitely. This behavior is by design to prevent the control file from growing uncontrollably. If the control file reaches its limit and Oracle cannot allocate space for new information, you may see error like this: Ora 00210 cannot open the specified control file. So what's the best practice to prevent this error is to use a catalog database. Relevance for each type of restore point. In case of normal restore point, when you create a restore point, its information is stored in control file and the flashback logs are retained based on DB flashback retention target value. Retention is not guaranteed. Logs may be deleted if FRA is full. Risk. What is the risk? You might lose the ability to flashback to that point if logs are deleted. In normal restore point, there is no guarantee of flashback logs, so there is a risk involved in this. Guaranteed restore point. So when you create a guaranteed restore point, the metadata is also stored in control file. Flashback logs never deleted until guaranteed restore point is dropped manually. Retention guaranteed. We can always flashback database to this point. What is the risk? No risk, but your FRA may run out of space if this restore point is kept longer. In our lab, we will check the settings of these two parameters by running the below commands. Also, we can set our desired values for these two parameters using alter system set command. So, what are the prerequisites required for creating a restore point? Number 1, database must be running on archive log mode. Number 2, database flashback must be enabled. And number 3, fast recovery area should be configured and large enough to store flashback logs. Alright, enough theory. Now we'll jump onto our lab and practice it in a rack environment. In this section, we'll see how to create restore point and how to restore the database using this restore point. These are the few steps we need to follow for this lab. First, enable the flashback if it is not already enabled. Second, we'll set the FRA. Third, create a table and add some records. Next, we'll create a normal restore point or a guaranteed restore point. That depends on your requirement. Next, we'll drop the table. We assume that someone has accidentally dropped a table. Now we need to restore the database. There might be other cases where upgrade failed or any other schema changes which went wrong and we need to restore the database. These are the steps to restore a database using the restore point created earlier. First, we'll stop the database. As this is a rack database, I'll use srvctl to stop all instances. Next, we'll restore the database. So these are the steps we need to follow to restore the database. I'll show you in the lab. At last, we'll validate the status of the table. Alright, it's time for the lab session. So I have logged into my database node 1 and let me see what are the databases running here first. Okay, so there are two databases running here, ORCL and ggprod. So I will use ORCL for this session. Okay, so I have set my environment as ORCL1. Let me check the status of the flashback first. I'll copy this. Log into the database as sysdba and run this command. So as you can see, my flashback on parameter is set to no, so we need to enable this first. Okay, I need to follow these steps, so I'll stop the database exit from here. Let me clear the screen. So I'm stopping the database first. Okay, my database is stopped. Let me check the status. So database is not running on both the nodes. So database is completely down now. So what is the next step? Okay, we'll start up in mount state. Then enable the flashback. Stop the database. Now we are this screen. Now we'll start the database. In fact, I forgot to add the step to start the database. Please keep that in mind. So I am starting the database now. Okay, database has started. Let me log into the database as is DB. Now we'll see the parameter DB recovery file dest. If it is not set, we can set it. In my case, I'm using record disk group. So this is already set and the size you can see it is allocated 10 GB for this FRA. Also, we can quickly check control file record keep time. Let me go back to the slide. Control file record keep time is set to 15 days. That's okay. Now we can check show parameter DB flashback retention target. So this is set to 1440. If you want, you can change this value. The value is changed from 1 day to 2 days. Now step 1 and step 2 are completed. We'll go to the next page. Okay, we'll create a table and insert some records. This is a very simple table. Clear the screen. Table is created. I'll insert 2 records. Record 1 added. Add 1 more record and commit. So if you see this table, you run select on this table, you'll see there are 2 records. Now we'll create a restore point. I'll create a normal restore point. So restore point is created. Now if you want to check the status of the restore point, you can run this command. So here you can see this is my restore point name and this is not guaranteed restore point. So this is a normal restore point. Okay, clear the screen. Okay, now we'll drop the table. Table is dropped. Now try to select data from table. You'll see error message. Okay, because table is dropped. Now we'll try to flashback the database using restore point. Okay, to flashback the database, we need to stop the database first. Exit from here. Stop the database. Okay, database is stopped. Log into the database. Start up in mount mode, and then you can quickly check the restore point name. Let me clear the screen. So this is my restore point. So I'll restore the database back to this point. So this is a command to restore your database. Okay, flashback complete. You can check the restore point again. Now open the database in reset log mode. All right, database is open. Now validate. My database is restored using the restore point we created. We need to validate to select the table. Yes, we can see the records. That means the database is successfully restored from the restore point. That's all for this session on restore points in Oracle. I hope this video helped you understand the concept clearly and gave you confidence to try it out in your own setup. If you found it useful, don't forget to like the video, subscribe to the channel, and share it with the others. Thanks for watching and see you in the next video.